Hello, we are Group 1. Welcome to this journey into the fascinating world of pharmaceutical chemistry. Today, we'll explore analytical methods, both qualitative and quantitative, and how they help us understand the chemical composition of substances. First, let's understand the two main types of analysis. Quantitative analysis focuses on determining the exact amount of a compound in a sample. Meanwhile, qualitative analysis identifies what elements or compounds are present. Here's the step-by-step process for any chemical analysis. 1. Define the problem, understand the purpose and requirements. 2. Choose the appropriate method. 3. Obtain a representative sample. 4. Prepare the sample for analysis. 5. Separate the components, if needed. 6. Measure the analyte. 7. Process and report the data. Depending on the sample and goals, you can choose from various: gravimetry, which measures the weight of a pure compound; titrometry, which uses chemical reactions to find concentrations; chromatography and spectrometry, often combined for separation and identification. In pharmaceutical chemistry, understanding acidity and basicity is crucial. We use the pH scale to express acidity and the Henderson-Hasselbalch equation to calculate pH for buffer solutions. This helps us maintain the stability and effectiveness of drugs. Did you know that the ionization of a drug molecule can affect its absorption and distribution in the body? By understanding the relationship between pK and pH, we can predict how a drug will behave in various environments. According to the American Chemical Society's Chemistry Division analysis, as in Christian 2003, chemistry analysis is defined as a way of measuring composition chemical reactions to natural or artificial ingredients. 1. Problem definition. Know what information is needed, who needs it, for what purpose, and the type of sample to be analyzed. The definition of this problem is also related to related analytical information, with a high level of accuracy and precision needed. 2. Selection of techniques and methods analysis. Selection of the best analysis techniques and methods will be used for sample analysis. Should pay attention whether to use chromatography, spectrophotometry, titrometry, or with the others. 3. Sampling. General analysis procedures carried out on a small number material to be analyzed. 4. Sample preparation for analysis. In general, the first stage of the procedure sample analysis is by measure the sample to be analyzed, the number of sample volumes or sample weight to be taken. 5. Sample pretreatment. This stage is related to the separation method. Election separation techniques for a specific situation depends on a number of factors. This technique is generally chosen based on the required accuracy and precision. 6. Analyte measurement desired. At this stage we learn that there are various physical and chemical properties which can be used as a method to identify and measure qualitative and quantitative on components in a material. 7. Calculation and interpretation of analytical data. This is the concentration of the analyte in the sample solution has been determined, then the results obtained will be used to calculate the amount of analyte in the initial sample. Good absolute or relative amounts. Method macro. A macro sample is samples that have weight greater than 100 milligrams. Semi-macro method. Semi-macro samples weigh between 10 to 100 milligrams. Micro method. While micro samples usually have heavy weight less than 10 milligrams. Weighing by difference. In differential weighing, the weight of the sample is the difference between two weights. This is the weight of the container before and after the analyst removes the sample from the container. In weighing by addition, the weight of the sample is the difference between the weight of the container with the sample and the weight of the empty container. 1. Analysis objectives, costs required, and time required. 2. Expected analyte levels and ranges and required detection limits. 3. The type of sample to be analyzed as well as the pre-treatment of the sample carried out. Put it down. 4. Number of samples analyzed. 5. The desired accuracy and thoroughness for quantitative analysis. 6. Availability of certified reference materials. Certified reference materials, standard compounds, reference standards, chemicals, and solvents needed. 7. Equipment that has been calibrated and meets the available performance requirements. 8. The possibility of interference at the time of detection or at the time sample measurements. 1. Absolute analysis, measuring the absolute amount of a component in a sample without compare it with a standard or reference. The results are usually in units precise mass or concentration, such as grams or molarity. Example, gravimetry and titrimetry. 2. Relative analysis, measuring the number of components by comparing them against a standard or reference. The results are more comparative, like in percent or ratio, right absolute value. Example, chromatography and spectrometry. 1. Gravimetry is a quantitative analysis technique based on measurements the weight of a pure compound after separating it from other components in sample. This method involves separating substances in solid form usually by settling, drying, and weighing substances. Titrimetry is a quantitative analysis technique that involves addition standard solution of known concentration into the sample. A complete chemical reaction occurs. The amount of standard solution required for completed reaction is used to calculate the concentration of the analyte in sample. Spectroscopic techniques can involve the emission or absorption of electrical radiation magnetic over a wide energy range, and can be used for analysis qualitative and quantitative, and can provide information on the chemical structure of the analytes from major to minor levels. Chromatography techniques can be used as a means of separation components in a mixture, and simultaneously can be used for qualitative and quantitative analysis. A combination of chromatographic techniques with spectrometry provides an excellent way to separate and identify compounds not yet known. Thank you for watching, and stay curious.